Thank you, Mr. President, for your kind introduction. Okay, first of all, it's always great to receive awards than giving. So, as I'm getting old, understanding those things really. So, first of all, congratulations to all of you, mostly the students, my senior colleagues. And we should start with a completely different thing. That is, those students who are coming to the institutes. So the first statement is no ragging. No ragging, period. And the students who are in the first year, they shouldn't allow their seniors to get into those acts. So this should be our message. We are having several very pathetic incidences in our city. So we should be careful, we all. So with this, so first of all, I'm extremely honored to get an invitation for Professor B.M. Dash Memorial Lecture on the 73rd Foundation Day of ILTA. And I really do not know why I am invited. Because this technology domain, which is so deep, so old, and in fact in our state also, in our city also, we have so rich a culture of these things, starting from areas related to Topshia to Bantala. We always discuss about this industry. We always discuss about how we can advance ourselves with this industry. And like many other industry, this industry also has several problems. And the people who are working with this for very long time, and we must remember Professor B.M. Dash, that they have much deeper knowledge than myself. But these kinds of talks, these are not that we can talk about our research for 100 or 200 years, percolate everything to the students. So our main motivation is to keep some part of entertainment. The talk is not really a class teaching kind of thing. Little bit of talking about computation, because we all know that we cannot come out of the gamut of computation in recent days. And this development, actually, I am personally fortunate to observe the development of computation starting from 80s, where the kind of memory, it might make some sound. So the amount of memory, the amount of processing power, the amount of this kind of thing to store, this would have taken a complete room in 1980s. So my first involvement after passing out from Jadavpur Electronics is in railway reservation system. That was in Koilaghat, those who know, a place close to Esplanade near the Ganges River, and we had to stay awake whole night to maintain the whole system. In the morning, people will come in the queue. So it was, you believe, it was 1992, that time. Around India, there was the ticket booking system of Indian Railways. And the system was, there was some kind of flat files, not exactly database. Some part of the programs were written in Fortran on a VAX 80, on several VAX 8650 systems. So and it worked. And nowadays we have advanced a lot. So what I would touch, I would try to touch the evolution of computing, its societal impact, and then I will try to move through little bit of three names, Boole, Turing, and Feynman. Those three persons are actually, in my belief, there are thousands of contributors to the development of computing, but we talk about these three persons, and I'll try to explain why I'm talking about them. We would talk about Professor B.M. Dash. I must accept that I really didn't know much about him, but when I had to give this memorial lecture, I really got the opportunity to study about his life and works, and really I would love to compare him might be with Sukumar Rai, who was very famous for bringing printing technology to our state, to our city. So that time, the kind of Bengal we had, just after the Renaissance in early 20th century, 1900 plus, the kind of scenario we had, we are missing a lot of that. But that is also some kind of self-criticism. So possibly comparing with the whole world, the situation we were at that time in terms of soccer to culture, we are not in the same situation. So we should introspect where we are missing, what we are missing. After that, I would like to talk a little bit about ILTA. Again, about Professor B.M. Das or ILTA, I took most of the material from your senior professors. They have kindly communicated me some materials. Then I had tried to study a little bit. Regarding MSME, from political perspective, I really have certain kind of knowledge, how it should, because I also, apart from my work in computer science, I try to work as an independent and unbiased political commentator. So from that aspect, in our country, our dream is every people should get food. We have calculated that around 20 crore families who are not very rich in India, if we can give them 10,000 rupees per month, there shouldn't be much problem for our national government. And related to that, this MSME kind of thing, micro, small and medium scale enterprises, they are also, the government has lot to do. All the industries won't be multinational. All the industries won't survive in a big way. Helicopters won't land on the rooftop of most of the industries. But to reach our vast country, different corners of that, given that we have very strong agricultural sector, we really have to decide that in development of industry, where we will put more effort, the human strength, our mind, our thinking. On the other hand, the share market, computation, AI, ML, and all these things. So it is very important for the decision makers of our country how we should proceed. We can advance a lot with developments in computation, but at the same time we have to remember that we are shrinking the job market. So if everything is done by machine, then what the human race will do, that question will always be there. And micro, small and medium scale industries, their development is not only dependent on huge automation, but mainly it should focus on human behavior, human appreciation, how people are participating in this domain. And we have to understand very clearly that the nice environment where we are sitting, talking, discussing, that is not the actual environment of leather industry, where we have to get down into lot of processes where things are not simple. So this talk would always fail to cover the actual problem of leather industry, and where ILTA is leading, they are thinking about these problems. There will always be limitation in any effort, because everything is not something like a problem like find the prime number between 14 to 18, where you have a clear answer. So these problems are multidimensional. On the other hand, we can use computers to see how we are proceeding. Even we need a computer to keep a list of our workers, to draw a graph how their salary is increasing, to see how the market price is increasing, and to decide whether the per-day labor charge, when we are including daily laborers in our system, should it be increased from some 280 rupees to 720 rupees or not. That will give us survival of our people, survival of the worker, and at the same time, hand in hand, we have to use computational things. So, application of computing we try to touch. Why did we get computers? Now, if we look at Industrial Revolution, 1760 to 1840, so transition of new manufacturing processes in Great Britain, continental Europe, and the United States, 1760 to about 1820, 1840. The transition included hand production methods to machines, new chemical manufacturing, which is still relevant in leather industry, iron production, increasing use of steam and water power, development of machine tools, and rise of mechanized factory system, and finally, capital. When in Bengali we tell Puji. But capital is not capitalism. We won't have time to discuss about the thesis and antithesis of Marx. But capital is important because it generates work and it generates several other things which are used for the advancement of the society. And from the capital, when we get dividend, how we will divide that among the people, that is decided by the people who are in power. And they are, at this point of time, around 750 crore people around the world. They are under different kinds of regime, some leftist, some rightist, autocratic, democratic, and all these things. And the race continues with lots of debates and discussions. Then we come to revolution of computation. Generally, like industrial revolution, we do not have any term for computational revolution or something. So I tried to study it a little bit, and so I call it revolution of computation, which started around 1930. But long before that, George Boole in 19th century pointed out that most of the mathematics can be handled in binary. And how that helped? That helped in a manner that if you can somehow manage 0 volt and 5 volt, and if you can consider 5 volt as 1 and 0 volt as 0, with that you can develop in one side circuits and in another side mathematics, where those mathematics can be interpreted or implemented on those circuits. So actually there are certain concepts of universal machine or Turing machine that will come after some time. And so basic model of classical computers, more general, more theoretical, but more close towards the application domain. The models were proposed by Alan Turing, von Neumann, and several other researchers in 1930s and the decades after that. The model of computers that Turing and Neumann studied are limited by classical physics and thus termed as classical computer. End of 19th century, till that time, most scientists believed that Newtonian laws governing the motion of material bodies and Maxwell's theory of electromagnetism, those are the main motivator of physics. And then there is another revolution from 1980. Quantum computation related ideas that gained momentum in 60s. A basic model was presented by Richard Feynman, and he has proposed some seminal idea of universal quantum simulator, and most of the developments are in 21st century so far what we have. We are seeing that development, lots of debate, but we should remember that this is a far more advanced computational model over the classical computers field is developing. So how do we compare these two revolutions? These two revolutions in history, we always try to compare things. When we have the Battle of Panipat, the first one and the second one. The first one is something like 16 or 17 something, right? 1726, and then 1759 is second battle. Battle of Waterloo, how is it related to some battle of Russia and Ukraine? So these, we try to compare history. So one part was muscle, the other part was brain. Very simple issue is, it is hard to force people to work. Continuously, if you want people to work day and night, they will revolt. Human parts cannot be assembled to generate another human. So I have 4 or 5 machines. I take one part of this machine, another part of this machine. I can create one machine, but you can't take a kidney, a liver, an appendix, and all those things, one brain, and put together to get a human being. Not possible. That is a limitation. And then all those things came out, the famous history of 1886 of May Day, where people protested for their rights, and you should also watch Modern Times by Charlie Chaplin. You can understand the situation of that time. So, social and political scientists at that time were actually top grade intellectuals. So, we are talking about Marx and Engels. So, they were not only social scientists, they also talked about mathematical things, and there is a very famous book which is known as Mathematical Manuscripts of Karl Marx. So similarly also, in our state, different political thinking came. Netaji Subhash Bose to Shyama Prasad Mukherjee, there are debates about their thinking, but those people actually guided us towards advancement. So we really need people who are intellectuals, who understand mathematics or physics in politics. Because they have to see how the technology develops. They have to understand how the technology develops. If they have to depend on many other people to get that understanding, then the probability of getting correct information decreases. So life of Boole, English mathematician, philosopher and logician. So that time in Europe, many of the people who are working with science were great philosophers, which is not the situation of recent time. Most of us, where we are studying, say, electronics or computer science or leather technology, we read very little amount of other subjects, even for our interests. And there are reasons, because we have a mobile phone in hand, so much material is coming there that most of the time in the day are lost. So, how we should proceed, we have to decide. We should introspect, stand before the mirror and understand. But generally the trend is, one mathematician was a philosopher at that point of time. Now if we look at a professor who is teaching mathematics in a top institute, generally he or she won't think much about philosophy. So he worked in differential equations and algebraic logic. His famous book, The Laws of Thought. So now I would attempt to run a video about him. Let's see if it works. Please remind me when I'm close to the end so that I can finish in time.
His work in symbolic algebra is the root of today's technology.
He's discovering and inventing new languages that can describe things in a mathematical way.
George Boole developed the foundation of computer logic.
The 1 for on and the 0 for off.
And yet, his contributions have been historically overlooked.
No George Boole, no Google, no Amazon.
The story of how a poor Irishman changed the world on The Genius of George Boole.
Thank you, it worked actually. So you can now search, these are taken from web, standard material. So, okay, so while we are bringing this, so presently, so there is a George Boole International Prize. So we give it once every year from Norway. And this is actually my area of work, and I am in the committee to decide who will get that prize. So this is a very interesting area of computer science where we work on Boolean functions. So very interesting now. These are the stories of big people. So in November 1864, Boole walked in heavy rain, went to his office and taught in wet clothes, and he developed pneumonia generally, came back, and that time there was a thinking that if you had pneumonia, if you are wrapped by wet material, then you will get well soon. But that didn't happen naturally, because science never tells that. And Unfortunately, he died in 1864. So his technical contributions relate to Boolean logic, Boolean function, implementation issues of classical circuits, combinational logic, sequential logic towards classical computational model. Then we talk about Turing, the English mathematician, computer scientist, logician, cryptanalyst, Second World War. We will talk about one movie very soon, philosopher and theoretical biologist. So you can see the kind of areas he worked on. Say theoretical computer science, formalization of the concepts of algorithm and computation. This is known as Turing machine, widely considered to be father of theoretical computer science and artificial intelligence. Nowadays, many people are talking about AI ML. His famous paper, which later was the name of a movie on his life, The Imitation Game. So that movie trailer I would like you to show, and I would give all the students an assignment to watch that movie. So, and the famous Turing Award is the annual prize given by the Association for Computing Machinery, ACM, for contributions of lasting and major technical importance to computer science. So this is a famous movie's trailer I am showing.
This war, we're not winning it. If you speak a word of what I'm about to show you, you will be executed for high treason.
It's beautiful. It's the greatest encryption device in history, and the Germans use it for all communications.
Everyone thinks Enigma is unbreakable.
Let me try, and we'll know for sure.
Mr. Turing, do you know how many died because of it?
I don't.
3, while we've been having this conversation.
Gentlemen, meet Mr. Turing.
We used to work together then. I'm afraid these men would only slow me down.
Popular at school, were you?
We're short on staff.
We get more staff then.
So this death of Turing is another part of history. So I won't get into details. I would ask you to read that on your own. So he died at a very young age of 41, and actually there is a belief that he committed suicide. Some people believe that he was murdered. So there is a very deep history of Alan Matheson Turing. So his contributions are computational models, Turing machine, von Neumann architecture related things, contribution to AI, and cryptanalysis, which has huge effect on the outcome of Second World War. Actually, some people believe that the kind of cryptanalysis, breaking codes, the kind of work the British mathematician did at that point of time actually changed the way of the war. And then very famous Feynman, Richard Phillips Feynman, American theoretical physicist, was involved in Manhattan Project, which is, you know, related to the atom bombs. You have a very recent movie which is going on. So have any of you watched that movie? So, okay. So one of the best known scientists in the world assisted development of atomic bomb, became known to a wide public in 80s as a member of Rogers Commission. So the Space Shuttle Challenger disaster was there, and then he was in the committee. He has very famous autobiographical books. Surely You Are Joking, Mr. Feynman, and What Do You Care, What Other People Think. Very nice books, you can read them. 3-volume publication of his undergraduate lectures. Very famous books. Many of you might have bought those books. Feynman has been credited with pioneering the field of quantum computing, which I told. So these 3 people, there is a video I would like to show later. He was also very political. So he tried to visit Russia actually. There is a very famous Tuvan Autonomous Soviet Socialist Republic. Again, you should read the history of that place. He was planning to go there, but the relationship between USA and Russia was still not very clear at that time. And finally, he couldn't visit, he died. His daughter finally visits. His last words are very interesting. I would hate to die twice, it's so boring. His related technical contributions are idea of quantum simulator, basics of quantum computing, factorization problem, and then later we had Shor's algorithm, which are very important implication on cryptanalysis. So that came in 90s. So we need quantum preparedness. Just to give you the information, that another domain of computing that is coming with, which is very big, is the quantum computing. So this has certain importance in physics. People are getting Nobel Prize in this domain. People are getting motivated to work in this domain. So how the computation moved. So actually what we wanted, like we had power of muscles, then we have power of brain, and we cannot put people to work continuously on adding or subtracting some numbers. We want those things to be done by machines. Then we come to Professor B.M. Das. He is the father of modern tanning industry in India, not West Bengal, in India. He was born in Faridpur. That time we had Bangladesh, undivided Bengal. He stood first in MA degree. That time we didn't talk MSc or all those things. In Calcutta University also everything was MA. Even in Jadavpur University possibly we still have in economics BA and MA kind of degrees. And in Oxford or many other places we use the word arts, Bachelor or Master of Arts. And then he met Prafulla Chandra Roy, who is very famous to the Bengalis for his entrepreneurship and his capability in chemistry or chemical engineering. So he was at that time head of the Department of Chemistry, the Presidency College, and he rightly identified his talent, provided an opening for Mr. Das in Bengal Chemical. Many of the old people would remember Kalmeg. So he provided an opening there for pharmaceutical works. So under the guidance of P.C. Roy, he evolved an easy process of manufacturing commercial sulfuric acid. Later, Sir Ashutosh Mukherjee awarded Mr. Das the Guru Prasanna Ghosh Scholarship to go abroad, very famous scholarship at that point of time, to study leather chemistry. He was awarded the MSc degree in 1911. Just to point out two big persons. Turing was born in 1912, Feynman in 1918. At that time, Professor B.M. Das is completing his MSc degree in 1911. So illuminated was Bengal at that time. So illuminated, so many contributions. Raman worked in Calcutta University to get a Nobel Prize. Rabindranath Tagore, all the stalwarts guided us in not only development of our state, but also development of our country and developing the whole world. So when we are talking about Professor B.M. Das, we should still expect, we should hope that in some days we would get many such professors among us who would guide any kind of industry in our domain. So a scholar as well as a firm believer of translating theoretical knowledge into practice in the field of leather manufacture to establish leather industry in India in a scientific line. So sure, we will break a coconut when we are starting an industry, but that's not science, that's the belief. And when we are working on science, we should only depend on the laws of science. There God will bless us, but God won't be able to write new laws of physics or new laws of science. So there is a difference between proof and belief. One part is belief that I can work very well, but another part is science where we need the scientific acumen to understand how we should proceed with science and reach the goal which is understood and controlled by a scientific model. So he proceeded to Germany and Italy. This is the time, because I already told about industrial revolution in 16 to 1700, and that time, by this time, Europe was actually flourishing with industries. He returned to India in early 1914. The World War has just started. He joined National Tannery, the first chrome tannery. Again, don't ask me what is a chrome tannery, the definitions. Your professors are here. They can tell much better. So he realized that the Indian tanning industry should be expanded and brought to a scientific line through application of modern technology. This is very important. The application of modern technology does not mean computing and computers only. When a piece of leather, when we are working on that, I would talk about one computational problem, how complicated it can be. So he was a leader, as we have already told, one of the founders of Bengal Tanning Institute, now known as Government College of Engineering and Leather Technology. The idea was mooted out by Dr. Nilratan Sarkar, who founded the Calcutta Research Tannery 1914 and later named it Bengal Tanning Institute. Professor Das was instrumental in taking the lead in attracting educated young men. His pupils were the experts and pioneers. So a professor is known by his students. So his students were also very well known. They worked in India and abroad, advanced education and research. So pioneering work of the institute in leather research conducted under his guidance solved many problems and brought out improvement of the quality of leather in Indian leather industry. On theory, Das Stiasne theory, he has worked on that. Indian Leather Technologies Association was born in 1950. Professor B.M. Das was the founder president of the association, and the foundation day is today. Once again, I'm extremely honored that you kindly considered me to talk about this thing. He was appointed as the first director of Central Leather Research Institute. The webpage clri.org, I had a look, quite a nice webpage where you can get lots of information. And there is a very nice compendium book I have seen, which is also interesting. You can just download that, or you all have already downloaded. The first symposium was ever held in the history of leather industry was in Indian Museum Hall in 1956. So what are the objectives that I studied? To bring all concerned with the broad spectrum of the leather industry under one umbrella. This is something very important nowadays. You would find many places under one umbrella. If we can bring several things, then exchanging communications, getting papers smoothly, and all these things are much better. Second point is, yes, we had to go for scientific things. Third point is again important, to offer a common platform for all to interact with each other in order to understand each other's problems and prospects. Monthly journals and books are always important. Textbooks are there. To have interface between urban and rural sector. The main problem that we are having, and leather industry, you know that if it is in an urban environment, we have limitation of space. There are lots of issues related to environment. So there is a need that we have to have our industries around our country, at least when we are thinking about our country. People should not move towards the cities always. We should try to get things little outside the city. To assist planning commission, various government institutes, ministry and autonomous bodies to formulate appropriate policies, and this is very important. If a policy is decided by people who do not have good understanding about that industry, then the end result, first of all, it is extremely bad, because the people who are developing, who are writing those policies, they might not have knowledge about the ground truth. And the second thing, the effect is not understood on that day. The effect is understood after a few more years, and then by that time we already lost a huge amount of time. So this is very important, where surely I believe ILTA is very much in communication with our state government and the central governments. So practical training and providing skilled manpower is very important, and to conduct activities related to growth of export. So everything, when we are trying to profit a lot, we need to export things that we all know, any industry that works. So this is the scenario of MSME sector. It comprises nearly 63 million enterprises who contribute 30% of India's GDP, 45% to manufacturing, 40% to exports, and provides employment to more than 11 crore people as per the government data. So now the question will come that we need information from the banks that when we are leaving 10 lakh crores of rupees of loan, when we are telling that loan need not be returned to our banks and our country has to manage somehow, then we need to ask question that how much of that is lost in MSME sector or with our farmers, or out of that 10 lakh crores, a lot of money has been spent behind the multinationals. These data we need to know, we need to understand properly to frame our policies. And if we really find that the MSME sector, the small scale enterprises, they are returning money much better to our government than the multinationals, then government should push more and more money in this sector. Government has some policies they are pushing, but those clear data we need to understand. We need to check that among the leather industries, how much we are returning to the government, how much we are taking from the government. These data I did not find very easily over web. So this is an area of research which is not exactly leather technology research, but I would tell this would be some kind of leather economics where you need to understand and get exact data that I failed to obtain. So what should be the outlook of leather manufacturing industry, I think? So generally the sustainability, digitalization or digitization, that is important because automation, artificial intelligence, data analytics, etc. can improve the efficiency and accuracy, and there are innovations, regional shifts, regulations. I will quickly talk about computing. Is it only digitizations? Is it only managed by zeros and ones? Yes, things are generally discrete, but you know the limitation. You cannot write root 2 exactly in a computer because computer is a finite machine, but it is enough large so that all your problems can be solved. We have algorithms that can solve a problem perfectly or approximately. Heuristics are a class of algorithms that can provide approximate solutions, and the kind of work we have in leather industry, modeling, drawing things, cutting things properly, they are the kind of computation we need. Approximate solution works. So enough to have good approximate solution in certain cases. However, there might be some problem where almost perfect results are required, like if you need to maintain some temperature or that kind of thing, we should be very careful. So there are lots of computing applications, and most of the applications you will find that like maintaining historical reports, and these are generic for most of the industries. In inventory and production management, again it is generic for all the industries, not only leather. E-commerce and online retail, and data analysis and market research. Two things very important, more specifics should be understood here. One part is design and visualization. Here computer aided design and all these things, very important. So we should have those subjects in our course. And sustainability and environmental impact, how that can be managed with a lot of data so that we can minimize the pollution kinds of thing. That is another very important area of research related to leather technology with computing. I would just take 2-3 minutes to talk about a very specific research problem in our domain, which is very much related to leather industry. So the part nesting problem is the problem of arranging a set of plane irregularly. So generally plain kind, small parts, irregularly shaped, and we have to put them so that we can get a complete thing. So this is actually a problem related to computational geometry, very famous problem, but this has huge application in textile and leather industry, clothing industry. And so for a car seat, when we have to use certain pieces of leather, how can we place them together? So this kind of problem is a very specific computational research problem that I found that might be applied to the industry, and we have to see if the industry has certain issues related to these kinds of algorithms. There are people in computation, might be in computational geometry, where people should collaborate and cooperate. So there are algorithmic methods for solving this problem. So research is only necessary but not sufficient. So what is important? We need to understand the necessary and sufficient conditions, because in any industry there are so many variables and some of them are not under our control. There might be some government rule for which certain products cannot be sold. So many uncontrolled variables, and among those variables, manipulating them or not manipulating them, we need to optimize. So lots of variables to get a successful output. Many of them are random variables. Even the success is not properly defined in certain cases. The process is distributed adversarial process. Competitive companies, they are working. So need a small group of people to deliver who are working on mission, not on vision. Sometimes we are so much bogged down in vision that we forget the mission that we need to solve at that point of time. And avoid big names only with big vision and who have very little to deliver other than speaking about their past. We have to look at future. We need to know our history, but we should not recapitulate our history always. We should try to look forward. So an immediate step. Say I have come to give a talk here, you have invited me. So what could be our specific point of concern where we can solve some problem? So revise the papers and syllabi related to computing in the leather technology syllabus. One part must be aligned with leather technology, where people have to use those tools. The other part should be generic so that the students can shift to other area. So we will get better student if we know that if a student does not get a job in leather industry for some reason, he would write very nice Python code and get a job in information technology. This happens in several engineering domain. There are negative aspects of that a good mechanical engineering for more salary, joining a company which is in IT. But the students will be much more relieved while going through the course. Do we need to learn computers hardware? Yes, because leather industry, we might need lot of data acquisition. We need circuits for which we need domain knowledge to be understood from the leather technologies. What are the softwares we should learn? How to develop some softwares which are very costly. Purchasing a software might be very costly. Officially, we shouldn't copy a software. We should buy it. So if we can develop it on our own, so we can start this tomorrow to look at the syllabus. I tried to look at the syllabus of different courses where you are teaching computing. I believe there is room for improvement. Okay, I'm not running the music. So computer we have to use. Thank you very much. I'm not showing the other videos because time is limited. Thank you. I believe on these kinds of talks there cannot be any question, right?
Thank you, Dr. Moitra, for exhaustive lecture, and we have to discuss on this subject once again. The outline of our syllabus, etc., is being done. Anyway, I request our General Secretary, Sri Sushanta Mullik, to honor Dr. Moitra.
Thank you, Professor Mitra. So we have just finished the BM Das Memorial Lecture.